Hey everybody, we're going to talk about 4.6 today, and it's going to be all over equilateral and isosceles triangles. So I just want to remind you of a couple things. Please remember that an isosceles triangle is a triangle that has at least two congruent sides. So maybe I mark these congruent, and equilateral is when all the sides are the same. So they kind of are very similar. One just typically has two, one has all three the same. So make sure you know that. But what we do want to talk about today are the parts of an isosceles triangle that would be really important. So I went ahead and drew an isosceles triangle here for you. Go ahead and add that to your notes. We're going to label a couple different parts with their official names. So the two sides that are congruent that I have marked here, those are going to be called the legs. So here's a leg and here's a leg, okay, and they are always going to be the same. The base is going to be the side that is not the same. All right, so two legs and a base. Then we have two angles that are going to be the same. So maybe I mark these that are going to be the same. Those two angles right there are called the base angles. So I'm going to draw a little arrow out. That's called a base angle. And this is also called a base angle because they're two angles that touch the base. And then the very last one is going to be this top angle up here. Remember, this one will probably be different than the other two. And this right here is called the vertex angle. So having this picture in your notes is going to be really important because I'm going to refer to those vocab words. So make sure you draw this in, study it, know the difference between each part. That way, when I use those vocab words in class, it's a lot easier for you to know which part of the triangle I'm talking about. All right. Next, we're going to talk about two different rules or theorems. So the first one is called the isosceles triangle theorem, and we kind of touched on this a little bit in a previous section, but the isosceles triangle theorem just says if two sides are congruent, then that has to mean the two opposite angles are congruent. So in this particular picture, let's say I label my triangle ABC, and I said that angle or side AB was congruent to side BC. So if that's the case, so if two sides are congruent, there's my two sides, then the opposite angles from them, so opposite of my legs, would be the base angles, and those would have to be the same. So if I use this picture, I would say if segment AB is congruent to segment CB, then angle A must be congruent to angle C. All right, and we talked about that, like I said, in a previous section very briefly, but now this is where we formally are introducing it. The converse of that is just the reverse. So the reverse says if I know two angles are the same, so maybe I know these two angles are the same, then that means that my opposite sides would have to be the same. So if this is angle X and angle Y, I'd say if angle X is congruent to angle Y, then what would have to be true? Then let's see. Then that would mean that segment XG would have to be congruent to segment YG. So opposite side, opposite side. Okay. So really the only difference between these is which one you're given first. If you're given the sides first, that's the isosceles triangle theorem. If you're given the angles first, that's the converse of the isosceles triangle theorem. So it's just the reverse. Okay, so make sure you have those written down. That's going to be helpful when you're doing proofs or when you're trying to find missing lengths or measurements, knowing how those things are related. Next in our section is going to be just a quick example. So here I give you a picture and I want you to name two unmarked congruent angles. So that unmarked means they're not marked now, but ones that I could mark based on what I'm given. So here I've already got two angles that are marked because we can't use those. But what would be helpful? Well, looking for the sides that would be the same would be really helpful. So here's a side BD and here's a side BC. So remember our isosceles triangle theorem said if I know two sides are the same, then their opposite angles would have to be the same. So that means that angle D would have to be congruent to angle BCD. So I'm going to name these with three letters. So I'd say angle BDC. Remember, we name angles with 3 letters, and this is the vertex, the middle letter, has to be congruent to angle BCD. Notice that they're the same letters, but the order is important. D was the vertex of one, C was the vertex of the other. So angle BDC, that's the right one, is congruent to angle BCD. And the only reason I knew that is because these sides had to be congruent. So I just went across. So BD and BC were the legs, these were the 2 base angles. And we'd be done. All right, so in a portion of your homework today, you're going to be given a pretty complex picture, and you're going to have to mark things that are congruent or name things that are the same based on information they give you. So it'll change for every problem. My suggestion is mark what they give you and then see what you can tell based on that given information. All right. Next, we're going to talk about equilateral triangles. So equilateral triangles are the one that people typically like because they're a little easier. So remember, it's an equilateral triangle only if it's also equiangular. So just reminder, equilateral means all sides are congruent. And equiangular was a word we talked about in class, you should already have down. That means all the angles are congruent. So that's 2 words that we need to make sure we know. And just as a special reminder, if it's equilateral, that means every single angle is 60 degrees. Very important there as well. Okay, so if it's equilateral, always 60 degrees all the way around. So 60, 60, and 60. No exceptions. Okay? So let's use these concepts of isosceles and equilateral to help us solve for missing angles or missing variables. So here I've got an example, and this is what we've given. We're given triangle XYZ, and they tell us here that segment XY is 8 inches and segment ZY is 8 inches. So based on our picture alone, what kind of triangle would this be? Well, hopefully we'd see that it's isosceles. So that means that these 2 sides are the same, but they want us to find angle Z. So this is our missing angle. Well, remember from the isosceles triangle theorem that from our legs, the opposite angles are congruent. So that means if we don't know this one, maybe we call it X, then we also don't know that one. Okay, so they're the same, but we don't know them. So what we can do is use this angle 40 and our 2 x's to set up an equation. So going back to what we know about all triangles, we know all triangles, their 3 angles together add up to 180. So all 3 of them, not just one. So I'd say 40 plus my 2 bottom angles, or my 2 base angles, has to total 180. And now we can go ahead and solve. So if I combine like terms, x plus x is 2x. Okay. Then I could subtract 40 to the other side, and that gets me 2x is equal to 140. And then the last step is to divide both sides by 2. So what's 140 divided by 2? That gets us 70. So that means that the measure of angle Z is 70 degrees. So make sure you don't just put x equals 70. Make sure you answer what they ask. They ask for the angle, not just x. So sometimes you're going to have to plug it in to make sure you get your final answer. So 70 degrees. And we're done. So using the fact that these are isosceles helped us to determine that these 2 angles had to be congruent. If we didn't know that, we wouldn't have enough information to solve this particular problem. Okay? Same concept for this. Here, we just have 2 variables to solve for instead of 1. So in this particular problem, let's start solving for y first. So we know it's an isosceles triangle again because we have 2 segments that are the same, or 2 legs. And what we know is that this side and this side are marked congruent. So we can automatically set those equal to each other because they're sides. So 2y plus 2 has to equal 4y minus 2. And now we can go ahead and solve. So I'm going to subtract 2y to the other side. And I'm going to get 2 is equal to 2y minus 2. Then I can add this 2 from the right side over to the left. So these will cancel. So I get 4 equals 2y. And then finally, I can divide everything by 2. So I get that y is equal to 2. Lots of 2's in this problem. So there's our first answer by setting these equal. And we know they're equal because of their marking. So always look for the markings. Next, we know that the angles have to be the same, okay, because it's isosceles. So remember, base angles will be congruent. So we know that this angle has to match this one. Okay, so in order to solve this problem, we want to look and see what we know is true. So what do we know is true here? Well, we know that if these two things have to be the same, then this has to be 6x plus 8 as well, right? And now we have something in all three angles, so we can go ahead and set up an equation. So we can say the vertex angle, 80, plus our two base angles, so 6x plus 8 plus 6x plus 8. What does it have to total? Well, it has to add up all three to 180. All right, and now we can go ahead and start to simplify. So let's see, 6x and 6x, that's going to get us 12x. 80 plus 8 plus 8, that's going to get us positive 96 equals 180. And now we can go ahead and simplify from there. And our next step, we're going to go ahead and subtract 96 over to the other side. So when we do that, 180 minus 96 is 84. So we'll write that out. So 12x equals 84. And then we can divide both sides by 12. And when you do that, you should get 7. So here we get x equals 7. And you could always plug that value back in and make sure it works for your triangle. If you were to plug it back in and get negative angles, obviously that wouldn't be right. Or when you plug it back in, if they don't all add up to 180, then that means something's wrong there as well. And that really should be it for this section. So isosceles triangles, equilateral triangles, they have a lot of unique properties that will be helpful. So when you work on your assignment today, just be looking to see what things match up, what things are congruent, and make sure you study the vocab of the vertex angle, the legs, the base angles, and the base. Those will be really important to be able to identify those. And if you have any questions, jot those down and make sure you ask me in class. Thanks for listening.